So this is our simulation box. Here we are having plasma region of length L0, and this is total box of length Lx along the x direction and Ly along the y direction. The laser beam is going in this direction. We are having the periodic boundary as at y direction and the absorption boundary at x direction. These are the 4 cases we will deal with. In first case, the plasma density will be 0.2 times of critical density, and the intensity will be 10 to the power 14 watt per centimeter square. In case 2, density will be exactly equal to the critical density, and the intensity will be same. Again, the plasma density in third case will be 2 times of Nc, and in fourth case it will be 2 times of Nc, as well as the intensity will be 10 to the power 18 watt per centimeter square. Let's start it one by one. First, we will start with the density profile for the first case of 0.2 times of critical density and 10 to the power intensity. Okay, so remove this first. Add a curve. So this. Okay. Charge density. Draw. So this is the charge density at time t0. Now we can move it to other times. So this is very. We can see in movie form also. This will be like this. Okay. Now we can plot the electric field component along x, y, z directions. Let's first plot electric field along x direction. So Ex we have to plot. Draw it. At time t0 it is like this. Now it is moving. This is overall electrical component. We can see it in a movie form also, like this. Now let's check electric field component along the y direction. So we can see the laser beam propagation very clearly. Laser beam is coming in from this direction. So it is going like this. Here at -5, it has crossed the plasma boundary. As the critical density, as the density is less than the critical density, the laser can propagate throughout the plasma. So it is passing through the plasma like this, and it has crossed all the plasma boundary. We can see it in a movie form also. It will be like this. Also, if you want to plot the electric field along the z direction, it will at time t equals to 0, it will be like this and this. This is electric field along z direction. We can see it in movie form also, like this. Now let's see the magnetic field component along the x direction, that is Bx. So this is Bx at time t0 now. This was the magnetic field along the x direction. it is in movie form will be seen like this. Let's see the magnetic field component along the y direction. This is much like electric field component as x direction. Now let's plot the magnetic field along z direction. So this is our magnetic field along the z direction. There is no reflection. Wave is propagating, passing through the plasma. In movie form, it will be like this. So this was all magnetic field. The variations when we are considering the first case where the density is 0.2 times of critical density and the intensity is 10 to the 14 watts per centimeter square. We plotted the density, electric field x, y, z, and the magnetic field Vx, Vy, and Vz components. Now let's move to the another variety where we are considering the critical density as 1 times of Nc and the intensity is same. So let's plot all these curves for this case also. Okay, let's move this. One Nc or 10 to the power 2. Let's first plot density variation. So this is at the time t equals to 0, and this is this. Now this was magnetic field. Sorry, this was density profile. Now let's see the electric and magnetic field components. Electric field along the x direction. It will be like this. These are the boundary of plasma at -5 and +5. Now see the other component, that is EY component. So as the density is equal to the critical density, there will be reflection. You can see that now the wave is getting reflected. Next we will see the electric field component along z direction. So it will be like this. Okay. Now if we see the magnetic field component similarly, it is the magnetic field component along x. Magnetic field component along y will be like this. Now the last plot, magnetic field component along Z. It is reflecting at this vacuum plasma boundary. Okay. So this was the curve for critical density. Density equals to the one equal to the critical density, and the intensity equals to 10 to the power 14 watt per centimeter square. We plotted the density curve. We plotted the electric field along x, y, z, and magnetic field along x, y, z. Now let's move to the another case where the density is equal to 2 times of critical density. In this case, we will plot all these curves again. So let's first plot density profile. So this will be like this. Now, if we consider the fields, electric and magnetic fields, we can draw it from here. X component field, it will be like this. And the Y component field we can also draw. So it will be like this. There will be much more reflection. And if we plot the electric field along Z, it will also be like this. Now, if we plot the magnetic fields, X component, it will vary like this. Now, magnetic field Y component. Now, magnetic field Z component. Okay. This was all about third case where the density was 2 mc and the intensity was 10 to the power 14 watt per centimeter square. Now we plotted the electric field component XYZ and magnetic field components. Now the last one where the density is equal to the 0.2 times of critical density and the intensity is 10 to the power 18 watt per centimeter square. Okay, now we are plotting. This is our final curve. Let's open it. First, the density. So it will be like this. We can see there is some density variations at the boundary. Okay. Now let's move the fields plot. Let's first plot the electric field along the x direction. Now electric field along y direction. Now same electric field along z direction. This was electric field. Now we can plot the magnetic field also in the x direction. Now magnetic field along the y direction. Now last, the magnetic field along the z direction. So this is all about these four plots. So thank you. Hello.